Hi, my name is Oluwaseun Martins, and in this video, we're looking at the Matplotlib library. Now, Matplotlib library is a library by which we can visualize data in Python, particularly when we want to plot graphs, whatever sort of graphs that we want to plot from a particular data set. Maybe you want to do a bar graph, a pie chart, you want to do an histogram, you want to do maybe normal straight line plot, or even a scatter plot. You can always use the Matplotlib library in Python. So without wasting time, let's just switch to our Jupyter Notebook in VS Code. Alright, so this is the Matplotlib library, and like every other library in Python, you would first of all import that library. So I'm using the keyword import matplotlib.pyplot as plt. So that's the abbreviation that we'll be calling the matplotlib.pyplot library with. So once we run this line, the matplotlib library will be importing to your notebook from this line. So that took 4.4 seconds. So after that, you have data that you want to plot, that you want to show on the graph. So in this case, I have this identifier f that is having this list, which is 2, 3, 4, 5, 4, 6, 7, and 8. So plotting this identifier f using this plt.plot. Now the plot function in pandas will plot a straight line graph for you. So when you're saying plt.plot, you are going to plot your data in a straight line. Now the function itself takes in a number of arguments. It takes in the data, the x and y axis of the data. It takes in the label in case you want to do the legend. It takes in the label. It also takes the thickness or the line width for the line that you want to plot. It also takes the color of the line. These are arguments that will pass in later, but because this is the first time, I'm just putting the data alone. And also what Matplotlib does in Python is that if you put only one data there as your entry, Python will take this data that you put in by yourself as your y-axis, while the default index of those elements will be the x-axis. So in this case, in place of me putting plt.plot x, y, now this identifier f I put in here alone, Python has taken that as my y-axis. So my x-axis in this case will be the default index of 0 for 2, 1 for 3, 2 for 4, 3 for 6, 4 for 7, and 5 for 8. So once I run this now we can see that on the y-axis I have my 2 up until 8, which is my f data. That's on my y-axis. While on my x-axis I have 0, 1, 2, 3, 4, 5. That is the default index of this, and this, because I have not put it in. So Python figures out that okay, I'm going to plot this against the default index, because this plot takes in, if you look at the, you can see it plots x, y. So that is what it takes. It takes in plot x, y. So that's it. So but because I put in only one value, you're going to take that value, that's in identifier as my y data. So that's it. So also if you have the two axis value, so here f is 1, h is the other, and I'm plotting h against f. So f now coming first in this plot argument becomes my x axis, and h coming after will be my y axis. So plt.plot this. Now for every plot in Python, you have to use the plt.show, because if you don't, in some cases it might show, but when you are running Python on some other platforms without the plt.show, it will not show. So to be on the safe side, it's always good to just use your plt.show to show any plot that you are trying to work with in Python. So with the plt.show, you are sure that your plot will be shown. So in this case, you can see that 2, 3, 4, 5, 6, 7, 8, which is this, is on my x-axis, while 1, 2, 3, 4, 5, 6 is on my y-axis, just saying f, h. So it's taking f as my x because it's coming first as the first argument, and h is coming as the second argument, which is the y-axis with the plot. Also, you can specify, because by default Python would specify the range of your axis for you, but you can also specify the range of your axis by yourself. So in this case, I have the same data, f and h, but I want to specify my axis. So I'm saying plt.axis, in parentheses, I'm having this list. In this list, I'm specifying the minimum and the maximum value of my axis on x, and the minimum and the maximum value of my axis on the y-axis. So 0 minimum on the x-axis, 7 maximum on the x-axis, 0 minimum on the y-axis, 10 maximum on the y-axis. So if I run this, so plt.plot, h is my x, f is my y in this case, and plt.show. So if I run this, so you can see here that 0 to 10 is my y, 0 to 10, and 0 to 7 is my x, 0 to 7. So I can also, let me just change this so that I can see the plot better, and this is going to 8. Let me just run this. So you can see here, also I can just take this one back to 1 so that the plot can be shown better. So we see here, so x is from 1 to 6. So x is 1 to 6, and y is 0 to 8. You can see 0 to 8. I can even start y from 2 so that my plot will be very bold. So we see it, y from 2 to 8, yx from 1 to 6. So it makes my plot very, very visible. Now you can want to make your graph look very better. You can want to put your grid, you can want to add color, you might want to use a label so that I can use legend alongside your plot. So we are working with the same data, f and h. So here I'm creating a figure here, plt.figure. I'm saying my figure size is 10,5, which means the canvas size, this white that you see is the canvas. It should be 10 counts or 10 units on x-axis and 5 units on y-axis. So that is what I'm saying here. The canvas size, that white background that you see, should be 10 units on x-axis and 5 units on y-axis. So I'm trying to specify what my output will look like. So plt.plot. So I'm now plotting now. So h, f, this is my h, f, which is my data, which is this one I have up here. And I'm saying the label of this very plot equals this string of Fermi. That's the label. That's the, because some cases you might have multiple plots on the same graph, and you have to label each of the plots so that when you're putting your legend will pick the label of each of the plots so that I can properly identify which plot is showing on your graph. So I'm saying this first plot, the label of it is Fermi. So with this line, I'm saying plt.grid. I want to put a grid line on my plot, and I'm saying grid true because by default the grid is false. So that's why the grid did not show on this one, because by default the grid is false. So I'm saying plt.grid in parentheses true, comma, and the color of my grid, I'm saying it is red with this R in this quote, is R, and I'm putting it in the quote because it's a string in this case. So is R is red for the color, and I'm saying plt.title. The title of my plot is this, in this parenthesis, in this string. This is the title of my plot, so that will be at the top of the plot. And also the label on the x-axis, plt.x label is x-axis in this case, while plt.y y label is y-axis in this case. And I'm saying plot.legend. So the legend here will pick the label of the plot, which is Femi. That's what the legend will pick. And plot.show. If I run this now, we see. So the canvas here is 10 counts or 10 units on the x-axis and 5 units on the y-axis. Let me just vary that for you. Let me reduce it to 8. So 8,5. Now see, it's 8 on the x-axis and it's 5 on the y-axis. Now you can see that the grid is there now, and the grid is red. So the grid is true and the color is red. You can see here, learning plotting in Python. So that is the title that we have put there. And the x label is x-axis, which is coming here, and the y label is y-axis, which is equally coming there. And this is the legend itself. That's the Femi that the legend here is speaking. That this plot in this color, this is Femi. That is the label of that plot. Also, you can save your figure using the save fig function in Python. So you can use that to save your figure. So you will save your figure after you have shown your figure. So this is the data. Everything here is the same. So this is the save fig line. So I'll just change this to this. So to save this figure, so that will plt.savefig, and this is the name of the file that will be saved in that figure, and this is the file type, JPEG. You can put it as PNG if you want to save it as a PNG, or JPEG as a JPEG file. So you can see this is the figure itself, and if I go into directly where I'm working, I will have this file there. So let me just open that for you so that you can see. So here we see this is the file that we just created. Now this is the plot. This is the file directly where you're working. So you have saved this figure in there just by using this line plt.savefig, and in the parentheses you put in the file name and the file extension, the type of file that the file extension that you want the file to be saved as, in this case as JPEG. And because it's a string, that's why they are in quotes, as it is here. Now we can do a lot of plots. Different kind of plots can be done in Python using the Matplotlib. In this case, I want to do an histogram for you. So here I've import numpy as np. So I want to generate random number here. So np.random.rand, and I'm saying generate random number for me between 100 to 100. So to generate random number for me is 100 to 100. So I'm creating a figure here, and I'm saying the figure should have 5 units on x-axis, sorry, 8 units on x-axis and 5 units on y-axis. So plt.hist HIST will print and we will plot an histogram for you in Python. So the histogram data is stored in Y. So I'm saying my grid is true. I'm not putting color to my grid, so the default color will be shown. The title is this, the X label is this, the Y label is this, and I'm showing that plot. So it's going to take a while because I'm generating that number first here, and it's only loading the numpy library for the first time in this code. So you can see this is the histogram. Now histogram shows you the frequency in your data. So that is what this has done. Also, you can have your own data that you want to show as an histogram. In this case, I have this identifier population underscore age, and I have here this list that I've passed into this identifier population underscore age. In this case, I would need bins because the range of values that are divided into series of intervals. So the bins here will be where all of this will be stored, so that you can show them on each histogram. The frequency of each of them will be stored there. So to create the bins has to be of a regular interval because it is divided into series of intervals. So in this case, I'm creating a bin size of 10, 10. So the bin has to be of regular interval. So here I want to do a 10 by 10 bin size. So here I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10 elements. That's 10 elements. Then again, I have 0, 10, 20, 30, 40, 50, 60. You can see that intervals is equally in 10 places. So it is 10 by 10 being I've created here. So plc.hist in this case would be population underscore 8, bins in this case. Then my hist type is bar in this case, and my width of the bin of the bar is 0.8. The X label is age groups. The Y label is number of people, while the title is Instagram. Then I'm showing the plot. So this is the output that we have here. So here is the bar graph in Python using the Matplotlib. You have the data here already. So just creating the figure, specifying the unit of the canvas on the X and Y axis. So to plot a bar graph, just say plc.bar, and you have the data here will be these two data, h, f. So this h will be the x-axis, while the f will be the y-axis in this case, as it has been stated here, and the h here will be the center of each of the bar. It will fall at the center of each of the bar graphs that you have. So this is the title, this is the X label, this is the Y label, and I'm showing the plot here. So you can see that 1, 2, 3, 4, 5, 1, 2, 6 falls directly at the center of each of the bars. So 1 will fall directly at the center of 2, 2 will fall directly at the center of 3, 3 will fall directly at the center of 4. So that's what has been happening here. So this is the title, this is the x-axis that we set for X label, and this is the X label as x-axis, and y-axis for the Y label like we specified, and the title is bar plotting in Python like we have seen here. Then we can also do a pie chart. So a pie chart just shows us in percentage how a data are spread. So I have here an identifier X with these entries of 5,000, 1, 5, 2,500, and 2,000, and the expenses of each of those is for food, transport, credit card, accessories, and groceries. So, and I want to plot that as a pie chart. So, and I'm creating the figure here saying the canvas size is 8 by 5, and plc.pie. So in the case of pie chart, you don't have X and Y axis in the pie chart, just the data and the label of that data. So the labels in this case is expenses. That's the label. So you're going to pick food against 5,000, transport against 1.5, 2,000 against credit card, 500 against accessories, and 2,000 against groceries. So that's the label. Labels is expenses, and the legend will show you the legend just by the side. So let me just run this. So see, this is the legend. Okay, however, let me just locate that legend. So let me just also, because if you look at it, the VS Code is having a dark canvas, so that I can't really see what is there. So I want to also correct that. So from Matplotlib, here import style from Matplotlib. So from style, now I'm saying style.use. I'm using the ggplot, so that I want to just add some color to my plot. Also for the legend, I'll just use the lock function to properly locate the legend. So I'm using lock equals in brackets 1 on x-axis for the location of the legend and 0.5 on the y-axis. So let me run this so that I see. So you see now that I have a white background. This is because of the from Matplotlib import style. There's style.use ggplot that I've done here that I commented the other time, and in locating this legend, I'm saying locate this legend where my x is 1, because if you have this pie chart at the end of wherever your pie chart is, that's where the value of x will be 1, and at the center of your pie chart where your y will be 0.5. So that's why you can see that this legend is located at the center of this pie chart on y-axis and after the pie chart on x-axis. So that is location 1, 0.5. If I say 1, 1, you will see that this legend here will go up here. Let me just run that so that you can see that legend has gone up there. I don't want it to go up there. I want it to be around the center. So I want it as 0.5. 0.5. So that's why you have it here. If you want to bring it further down here, you just say 0. In this case, it will come down. You can see that it has come down, but it's covering the grocery. So I want to put it at the center here. So 0.5. So that's why you have it there. Also, you can do a scatter plot. So here I have two identifier x and y. So where I've used the numpy to generate random number 100, and also for y generate random number of 100. So I'm creating the canvas for my figure as 8 on x-axis and 5 units on y-axis, and I'm doing the scatter plot. So for the scatter plot, like we have done for the plt.plot for straight line, plt.hist for the histogram, and plt.bar for bar, and plt.pie for the pie chart, we use plt.scatter for the scatter plot. So, and you pass in your x and y argument into it, and after you do your plt.show. Also, you can use you can specify the color. Yeah, I'm just saying color equals string. Let me say k is black, so the dots you see now will be black dots. So you can see that that is black. And if I use m, that will be magenta. So we'll see. If you use y, will be yellow. So we'll see. So you can always change the color to whatever you want. So and plt.show. So that is for your scatter plot. Now you can combine plots. You can have multiple plots on the same graph. So doing that, you are going to plot the two graphs together on the same canvas just by putting in the data and using the plot function accordingly. So here I have the x underscore value, y underscore values, which are the values I want to plot in this case, and I'm creating the canvas here. So in this case, I say plt.plot x underscore values comma y underscore values, and the color here is magenta. Also, I'm saying here plt.scatter. So I'm doing a scatter plot and a straight line plot on the same graph. plt.scatter x value comma y underscore values, and I'm putting my grid. The grid is true and the color is red, and I'm showing that plot. So let me show that. So that is what we have. So you can see these are the dots for the scatter plot. So that makes me to see exactly where the points of the straight line is. It makes it easy for me to see that. So also you can create a subplot. in Python. Although we have not discussed how to create function, but here I've created a function using the def, and the function name is f, and the argument the function is taking is t. So this is the function, so the function is there. For this function returns np.exp minus t times np.cos 2 times pi t. All right, so these are your t values for t1 and t2. Anyway, let me just tell you about the plot. Now, to create a subplot, that means you want to create multiple canvas, on the same plot, multiple canvas on the same plot. So here I've created the instance of the figure. The figure should be of fixed size, 8 units on x-axis and 5 units on y-axis. Now for my subplot, plt.subplot. Now your subplot takes in the argument of the number of plots that you want on your canvas. In this case, I'm saying I want 2 plots. Now the next thing is the position of this very plot in that 2 plots that you created. So I'm saying this one should be on row 1 colon 1. That's what this means. Row 1 colon 1. That's what this means. And this 2 here means I have 2 plots, but the position of this one is row 1 colon 1. So this is the plt.plot itself is this. So the straight line or the line plot that we're plotting here is t1 comma f into t1. So this will be my x, this will be my y, and this would be my line type. It will be blue with the 0 as the dot, or the data point will be 0 and the line will be blue. So also the next line will be the t2 comma f into t2. Now this is the second subplot. So just the same way, there are 2 plots, but the position of these plots now would be position 2. That will be row 1 colon 2. This one is row 1 colon 1. That's the position of this one. Why this one is row 1 colon 2. So row 1 colon 2. So that will be 1 row 2 colon. The 2 plots is occupying 1 row 2 colon. So this will take in the first colon, while this one will take in the second colon. So let me just run this. So this is the second plot here. So this one I'm plotting in the second plot. So let me just run this. So we see this is the first plot, this is the second plot. So this is row 1 colon 1. This is row 1 colon 2. So I can also change this. Let me change this to, I change this to 2 colon and 2 colon. So let me see. So we see it. So I have 2 colon here. So this is the first colon, this is the second colon. So I can also change this back to what it was as 1 row. But this one will take, this first plot here will take the first position, while this one will take the second position. This plot here will take second position. So you can see not on a single row. That is subplot. Also, okay, I've talked about this already, to add colors to your plots. We have talked about that, how you put in colors already. Okay, we have talked about the GG plots. All right, I'm just showing here how you can put in the line width for your line plots. So just say line width, whatever line width you want to have. Line width equals 5 in this case. That's the line width I want to have, and I'm plotting the 2 multiple graphs on the same canvas. So I have here identifier x with its own data, identifier y with its own data, x2 with its own data, y2 with its own data. So plt.plot x comma y, the color of that is green, the label is plot 1, and the line width is 5. Then the next plot is plot x2, y2. Color is cyan, and label is plot 2, while the line which is equally is 5. So the title is color plot, the y label is y-axis, the x label is x-axis. The legend here is equally there. So by default, Python will find where to put the legend, but you can equally specify just like we did with the pie chart. In this case, I can say, okay, I want the legend to be at a location that is best in this plot. So log parenthesis best. So I want it to be at the best location. So yeah, it's saying this is the best location. All right, so we can do that. Also, I can just use the log. Say I want it to be on x. Okay, let me say x1, y0. Let's see where that will take it. So see, x1 after the last count on x, and y0, can see that is where the location is. This is where y is 0, because y is from this point up here. So y is 0 here, is 1 here. So the location is here on 0. If I put y equals 0.5, so it will be at the center of the graph. So we see this is where y is 0.5 for the log. But the best thing, just put it at the best location. Just say log best. So if we run this, so this is saying this is the best location for this plot. Also, I can convert this plot into a subplot just by saying, before I do the first plot, I'll say plt dot subplot, and I'm having two plots. And I'm saying I want 2 rows, and this one is taking the first position. So I'm going to just copy this, and before I take the second plot, I print this here. So this one will take the second position here. So we can see, so this first plot will be in the first position, while the second plot will be in this second position. So we see, this is it. And now we can see that this one is not having the grid, is because the grid is coming after the second plot. So that is why this one is having the grid, why this one is not having the grid. So let me just remove the subplots here, so that will return it to what it was. So this is it. Now you can equally have multiple bar graphs in the same graph. In this case, I have the first bar graph, plt.bar, with this data stored in it. This is my x, this is my y, and the color is black, and the label here is BMW, and the width of the bar is 0.2, and the second bar is this is the x, this is the y. The label of this case is Audi, and the color is blue, and the width is equally 0.2. The legend is there because I put labels in. So the legend will pick the label of each of the plots. X label is this, Y label is this, the title is this, and I'm showing the plot as this. So if I just run this, so we see this is what we have. So I have multiple bars on the same graph. Also, you can say you want to specify, in place of having on your bar graph, in place of having this 0, 1, 2, 3, 4, 6 on the x-axis, or even on the y-axis, you can say you want to specify what you want to appear here, a string that you want to appear here. In that case, for the x-axis, you'll be using the x ticks, and for the y-axis, you'll be using the y ticks. So let me just show you how to do that. Now you have here the data stored in y in this list, and also here the data stored in x in this list. So 1, 2, 3, 4, 5 for x, and I have here days, and I'm storing this list with this string of Monday to Friday in this list, which is stored in identifier days. So here I'm creating the figure to have 8 units on x-axis and 6 units on y-axis, and I'm saying, in this case, I have 5 bars, 40, 50, 70, 20, and 80. So plt.bar x, y, x, y. So the color here, I'm specifying that the first one should be blue. If I don't specify the color, Python will specify its own color, but in this case, I'm just saying I want to specify my colors myself. First one is blue, red, black, magenta, and yellow. And the width of the bar is 0.5. The label is daily temperature in this case. And my xticks, plt.xticks now. So what I want to do now is to say that for my x, in place of having this 1, 2, 3, 4, 5 on my x axis, I want to replace it with this Monday, Tuesday, Wednesday, Thursday, Friday. So next I'll be using the xticks. That will be plt.xticks x, which is this x, comma, days. So it's going to replace all the elements in x with days when plotting the bar graph. So 1 will be Monday, 2 will be Tuesday, 4 will be Wednesday, 5 Friday, and all of that. So the legend is still there. The legend will be located anywhere Python deems fit. Now the x label is days, and I'm putting in my font size for that to be 15. The y label is temp, and I'm putting my font size for that to be 12. And the temperature is daily temperature, and I'm putting the font size to be 16. I'm showing that plot. So we see here that in place of having 1, 2, 3, 4, 5, it has been replaced with Monday, Tuesday, Wednesday, Thursday, and Friday. And these are the colors we specified. And Python has put in here the legend here as this label that was specified here as the legend, which is what Python has specified here, and they has put it at this location. Also, you can, let me uncomment this line and put in this comment here. You can also make your figure look better by putting in some other details alongside your figure canvas you are specifying. In this case, I have 8 units on x-axis, 6 units on y, and the dot per inch in this case is 80. Now the face color is white, the color of my canvas is white, the face color is white, and the head color here is black. So let me just run this, you see the difference. If you look at it, you can see that this picture is better than the first one because of the DPI. If I increase my DPI to 100, it will be sharper. So we see it. So that is how you can make your figure look better. You can just add some more details alongside your plt.figure to make your figure look better. Also, you can have multiple bar graphs that shares the same xticks. Now, before I even do that, let me show you horizontal bar graph. If you want to plot horizontal bar graph, you just need to put a bar H here, and you run this. Okay, so now there's an error because I'm using width here. Let me just change that to height. So let me run this. So you can see it here now that I have it as horizontal lines. Now all of this one is squeezing here because I will need to change this to x, this to y. I need to change this also to y. So let me run this again and see what's going to happen. So see here that this has been changed here, and this one has been changed here. So that is that. Let me just return this to what it was. X, this is Y. So let me change this one from bar H to normal background. Okay, so what's the problem? Height. So change this back to width. So that corrects that. So you can have multiple backgrounds that shares the same X ticks. So in this case, I have two lists stored in this identifier Y, because these two bar graphs are sharing the same X ticks. So here I have index 0 is this is index 1. So this list is index 0, this list is index 1, and I'm storing that into identifier Y. And I'm also creating here a range of number using a NumPy library of 5 elements, because there are 5 elements in this list. 1 2 3 4 5, 1 2 3 4 5. So creating that range of 5 elements, and I'm using this identifier days also to have this list with this string of Monday to Friday. So this is my figure instance of the canvas, specifying the canvas type. I want 10 units on X and 8 units on Y. So I'm trying to plot the bar graph now. So my bar graph, plt.bar, X plus 0.00, comma, Y index 0, comma, color equals blue, the width is 0.25, the label here is Abeokuta. So let me just explain this line. Now, our bar graph takes in X, comma, Y. But in this case, I have two bar graphs sharing the same X ticks, the same X ticks. So this is index 0 in Y, this is index 1. So this first line is going to be printing Y square bracket 0, index 0. We're going to be printing this list against this X, which is what I'm doing here. And I'm saying the color of that is blue, and the width is this 0.25, and the label of that bar is Abeokuta. And here I'm saying X plus 0.25, comma, Y index 1. So it's going to be printing this, plotting this against this in this instance. Color is red, width is 0.25, label is Ota. So what is this 0.25 and 0.0? Now what this is doing is this, because my thickness here is 0.25. So if this one is starting to create its bar from 0 with a thickness of 0.25, so that means the thickness of this first bar will be 0.25. And if this one is starting from plus 0.25, that means this second bar will be plotted directly after this first bar, because this one is from 0 to 0.25, and this one is starting from 0.25. So they are going to lie just at the shoulder of each other. So that is what this is saying. So here I'm using the X ticks to convert the days into the X label, plt.xticks. This is the legend, and I'm using the best location for that. The X label is here, days, and the font size of 15. Y label is here, and the font size of 12, and title is here, the font size of 16. So let me just, so you can see here that they are lying just at the shoulder of each other. So this one is from 0 to 2.5, this one is from 2.5 to another 2.5. So let me just show you, and let me vary this. If this is 0 to 0.25, and I'm starting this one at 0.2, what will happen is that this one will be inside of this by 0.55. Let me run it. So you see, so you can see now that it's lapping now. So it's lapping each other now, because this one is having a thickness of 0.25, and this one is starting from 0.2. So that is why it's lapping with 0.05 into it. And if I put this one at 0.3, starting from 0.3, while this one has ended at 0.25, this one will be staying away from it by 0.05. So you see that gap there. So it depends on how you want them to be, but they will be sharing the same X ticks in this case. So with that, we have come to the end of this class. Thank you very much.